This is not a beginner friendly problem. If you are a beginner, save this video for later, go back to LeetCode, solve some easy questions and come back here. But if you feel ready, let's get on with this challenge. So what is this problem actually? Let's try to understand it first. So what does reconstruct itinerary means? Basically, we have a array of tickets from and to, and we need to construct like how we can go from one place to another, and we can go in multiple ways, but we want to return the least lexicographical order. So for example, in here we always start from JFK, that's given to us. We can go to D and A, but we should always decide to go to A first because that's the lexicographically smaller order. But sometimes there is a problem that if you go the smallest first, that might not be the complete itinerary. So then you have to come back and start from another path. If you have solved few graph problems, you would know how this works. Basically, we'll create adjacency list of this graph and then we'll traverse one by one using DFS. That's the first thing that will come to your mind. Second thing will come is how we can keep sorting this. So you will think of a solution that sort these initially and then iterate. That's good. And next problem is when you find that you can't go any further and it's not a complete itinerary, you backtrack and start the new path. So that's what you think if you have solved few problems, but in reality this doesn't work. So let me explain what happened with me. So I did exactly this. I sorted this list, I did run DFS, I managed the backtracking correctly by removing the nodes from my results, and I run the code. Boom, it worked. But then I submitted it and I got TLE. I was trying to solve this TLE issue for almost 10 plus hours and across 3 days. So I know the pain of how to solve this problem. And even after watching some videos or even after reading the solutions, I was not able to understand what's exactly happening. Be proud if you have solved this using DFS and recursion. That would work in the interview, but it won't work in the LeetCode. And to fix it and to understand this, let me show you a simple trick so that we can solve this problem. But if you want to really know and how to solve this problem, I would suggest you to look into these two algorithms. Now let's see how we can solve this problem. Okay, so I'm going to take this graph which has a lot of itineraries, and you can go back and forth. How to solve this problem with one simple trick is start building the itinerary from the end. So I'm gonna explain you with this example how to do that. So for that, let's create a variable stack, and this will start at JFK, always the first node, and we'll run a loop until the stack becomes empty. Before that, when you are building this adjacency list, so you need to sort these tickets into reverse order. So something like this. So for JFK, you want D to come first and A to come last. Yeah, in sorted order in descending. So once you have created this adjacency list in the reverse sorted order, let's run through this loop one more time. So you start at JFK, you have two options D and A. So in your adjacency list, you will have A as the last element. So you pop that and put it into your stack. You are in loop. So now you go back to A and you pop the last element from here. So pop it and add it to stack. Now you go to C and pop the last element from C, which is D. So you pop it here and add it into the stack. Now you go to D, you see B and A, but you pop the last element. So you pop A and add it here. Now when you go back to A, now this is empty. The adjacency list is no longer available. So here comes our result list, and you keep adding to it when there is no more further path to go down that route. So now that A has no more children, we can't go here. We pop it here from the stack now, and we add that to the result. So this is how it's gonna work. Now let's go ahead. So D. Um, so now last element in our stack is D, and we already have processed A. So we now have B. So this is gonna be another path now, and we're gonna go through this path. So how that will work is you have a D, you go back here, you see B as the next element to pop. So you pop here and add B. You go to B, you see C, you pop C, add C here. You go to C, you pop JFK, and you go to JFK, you pop D. Once you add D here, you go to D and you see there are no more neighbors, so we can end our loop here. So what we do is now we pop from this and add D here. Now we go back to JFK. JFK is done, so we pop it and add here, and we keep repeating this for all these nodes. So none of them have any more children, so we can't go deep, so we'll keep popping and adding to our result. So I went ahead and created this result list complete. One thing, if you notice, we are popping from back and we're adding it to our result. That is keeping our result in reverse order. So if you remember, we start from JFK. So JFK is at the end here. So we need to return result as reverse of it. Return reversed. So that is our solution. I know it's very complicated. I know you will not get it if you don't know these two algorithms. But the code is really simple, and I'm gonna show you that next. First thing we need to do is sort the tickets in reverse order so that we have smallest element at the last. So how we'll do that is sort the tickets dot sort, and we want them reversed, so reverse true. So now that we have tickets sorted, we'll make a adjacency list out of it. So let's call it graph is equal to default dict of list, and let's create this list. So for source and destination in tickets, graph of source dot append destination. So now that we have our adjacency list, we want to list for us. So first is stack, and this will have our JFK as the starting node, and we want another results array. Now the main point is we want to iterate over the stack is not null. So while stack, what we want to do is, if we want to check if stack has an element, so if it comes inside, stack will have an element, so take the last element of it, and if that last element's adjacency list is not empty, so graph of that element is not empty, then what we will do is we will add this last element to the stack, and we continue. So stack dot append the adjacency list dot pop. So basically what we are doing is we are taking the adjacency list of the last element in the stack, for example JFK, and we're gonna pop the last element. So whatever was lexicographically first will come out first. That's done. If otherwise else, that means this is empty. So we have processed all its neighbors. What we want to do is we will now add this to a result. Result.append stack dot pop. Okay, and we go and keep iterating over this. So that's all for this. Once we will have a results array and we can return the reversed order. So let me try and run it. It does pass, and let me submit it now. Yeah, it does work. If you found this video helpful, please like and subscribe, and see you in the next one.